Assalamualaikum and have a very good day. Today we're going to learn about metric inverse by using adjoint method. So what is inverse metric? Inverse metric, for example, metric A 2513, then inverse of metric A is 3 -5 -1 2. If A inverse exists, then metric A is invertible. So, as you can see, the product of metric A and A inverse equal to identity metric. The question is, find A inverse using adjoint method. There are 3 simple steps using adjoint method. Step 1 is to find metric cofactors, which is 9 cofactors, by using formula determinant A, AD minus BC. For step 2 is substitute this formula. Okay, for step 3, you should check your inverse by using this formula, which is product of metric A and A inverse equal to identity metric. So based on the question given and step 1, metric A, row 1, column 1. First, we should cover row 1 and cover column 1. As you can see, we'll get 2, 5 and 3, 1. Equal to 2 minus 15, and the answer is -13. Metric A, row 1, column 2, cover row 1, cover column 2, and as you can see, -1, 4, 5, 1, bracket equal to -1 minus 20, and the answer is -21. Okay, for metric 1, 3, cover row 1, cover column 3, and as you can see, -1, 2, 4, 3 equal to -3 minus 8, and then the answer is -11. For metric 2, 1, metric A 2, 1, as you can see, we get 2, 3, 3, 1 equal to 2 minus 9, and the answer is -7. For metric A 2, 2 equal to 1, 3, 4, 1 equal to 1 minus 12, the answer is -11. A 2, 3 equal to 1, 2, 4, 3, and the answer is 1 multiple 3 minus 4 multiple 2 equal to -5. For next cofactors, metric A 3, 1 equal to 2, 3, 2, 5, 2 multiple 5 minus 2 multiple 3, and the answer is 4. For A 3, 2 equal to 1, -1, 3, 5 equal to, the answer is 1 multiple 5 minus -1 multiple 3, the answer is 8. For metric A 3, 3 equal to 1, -1, 2, 2 equal to 1 multiple 2 minus -2 equal to 4. After that, write down all the 9 cofactors into 3 by 3 matrix. But this is not the final answer for cofactor matrix. This is the cofactor matrix from the all 9 cofactor matrix that we already did before. Okay, but then we must change the signs regarding to this. Negative, positive, negative, 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 positive, and negative, positive, negative, 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 positive, and negative, positive, negative, and negative, negative, positive, 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 negative, negative, positive, positive, positive. So basically, this is the final answers for cofactor matrix, because we need to change the sign first. After that, we're going to use the formula given. We should memorize it. But first, we need to find determinant of A and adjoint A. So this is the formula that we're going to use. A inverse equal to 1 over determinant A multiplied by adjoint A. What is adjoint A? Adjoint A is a is a transpose of cofactor matrix. So to find a transpose of cofactor matrix, we should change row into column. For example, row 1 into column 1, row 2 into column 2, and row 3 into column 3. So it will become like this: negative 13, 21, negative 11, 7, negative 11, 5, 4, negative 8, and 4. So this is the transpose of cofactor matrix. But how to find determinant A? We can find determinant A by using arrow method. So we write down all the matrix A. Okay, and then we add on column 1 and we add on column 2. By using arrow method, we should drag the arrow like this from 4, 2 until 3, and the answer is 24, and drag another arrow from 3, 5, 1, we get the answer 15, and drag another arrow from 1, negative 1, and 2, and the answer is negative 2, and drag another arrow like this from 1 to 2 and 2, 1 equal to 2, and drag another arrow like this 2, 5, 4, and the answer is 40, and drag another arrow like this from 3, negative 1, and 3, the answer is negative 9. So how to get the determinant of A? 2 plus 40 minus 9 bracket minus 24 plus 15 minus 2, and the answer is 33 minus 37, and the answer is negative 4. So we already get the transpose of cofactor matrix, and we already get the determinant of A. So basically we can use the formula given. So A inverse 1 over negative 4 bracket negative 13, 21, negative 11, 7, negative 11, 5, 4, negative 8, 4 bracket. After that, we multiply both and we'll get the inverse matrix of A. So this is the inverse matrix of A. How to check the final answer? A multiple A inverse equal to identity matrix. Okay, first we write down the matrix A. 1, 2, 3, negative 1, 2, 5, 4, 3, 1, and then multiple A inverse. We should write down A inverse 13 over 4, negative 7 over 4, and then negative 1, negative 21 over 4, 11 over 4, and then 2, 11 over 4, negative 5 over 4, negative 1 equal to, so the product of both will become identity matrix. So we must multiply both. Column 1, row 1, column 1. The answer is 1. Column, the answer is 0. The answer is 0. Multiply row 2, column 1. The answer is 0. Row 2, column 2. The answer is 1. Row 2, column 3 equal to 0. Row 3, column 1, 0. Row 3, column 2, 0. Row 3, column 3, 1. So as conclusion, matrix A is invertible because A inverse exists. For quick understanding, there are various ways to find inverse matrix, but to find inverse matrix using adjoint method, there are 3 simple ways. First, find nine cofactor matrix by using formula determinants. Second, substitute into the formula. Third, we should check the answers to make sure that the answer is correct by using formula matrix A multiple A inverse equal to identity matrix. So that's all from me. Thank you for listening to my teaching video.
JC